Hello, everyone. Welcome back. So, today we are going to be doing the double angle formulas from our trigonometric identities. So, what are the double angle formulas? There's one for sine as follows, and there's also one for tangent, and there's actually three different ones for cosine. Which, if you look closely at it, you recognize how all three of them are very much related, but we still have all three of those to work with. So these can be useful when we're trying to simplify expressions, when we're trying to prove trigonometric identities. Those kinds of things are why these double angle formulas can be useful. So whenever you see that there's a double angle, you can expand it into one of these forms or vice versa. If you see something that looks like it can be switched just to a double angle, then that could also help to simplify things if your goal is to simplify the expression. So depending what your goals are, this could be the formula that you're going to need in order to do that potentially. All right, so let's go ahead and talk about some examples here. So this first one here says simplify each of the following expressions and then evaluate their exact values. So we have 2 sine pi over 12 cos pi over 12. Well, this very much resembles the sine double angle formula. So basically, this is equal to, based on this formula, sine of pi over 12 times 2, right? So 2 times pi over 12 based on the double angle formula, which is equal to sine pi over 6. And we know that sine pi over 6, well, pi over 6 is is an angle from the special triangles. So if I draw that special triangle and just remind ourselves which one that is, it's the pi over 3 and pi over 6 special triangle, and it looks like this. Then we can clearly see that the sine of pi over 6 would be the opposite over the hypotenuse, which would be 1/2. So therefore, the answer is 1/2. So by using this double angle formula, we were able to really simplify this down, get it to something that makes a lot more sense, and then we were able to solve it very quickly and easily because we're aware of the special triangles and what they entail. And so that's good. Okay, next let's move on to B. Well, B has some tangents in it, so it clearly resembles this formula best. So the formula here is that tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. And looks like theta in this case is pi over 8. So this would be tan times 2 pi over 8, which is tan pi over 4. And pi over 4, it's also one of the angles in our special triangle, is a different one though. It's this one. It's the 1, 1, root 2 triangle, 1, 1, root 2, where we have pi over 4 and pi over 4 like that. So what is the tangent of pi over 4? That's the opposite over adjacent, which is 1 over 1. So the answer is just 1. So isn't that crazy? That complicated thing at the beginning is really just a fancy way of saying 1. That's wild. Okay, let's try C. Well, C has cosine in it, so I'm guessing it's one of these. It also looks like it has the minus 1 at the end, so I'm going to assume we're going to use this formula to determine it. This second formula right here. Okay? All right, so here we have 2 cosine squared pi over 6. So pi over 6 is theta, right? The double angle, the single angle, minus 1. So that means this is equal to cosine 2 pi over 6, which is cosine pi over 3, which pi over 3 is one of these special angles, right? Cosine of pi over 3, based on the special triangle we drew before, would be a half. So there we go. Awesome. Okay, let's do example 2, which is a little bit of a step further with this. It says if tan theta is negative 3 over 4 and x is between 3 pi over 2 and 2 pi inclusive, so that means it's in quadrant 4, determine the value of cos 2 theta and sine 2 theta. Okay, well, here's the thing. Here's the thing. We know that cos 2 theta is equal to cos squared theta minus sine squared theta, right? This is something we know. And if this is in the third quadrant, or sorry, quadrant 4, right? Because it's got to be between, here we have 0 and 2 pi. Here we have pi over 2, pi, and then 3 pi over 2. We know it's got to be in quadrant 4 because it's got to be between 2 pi and 3 pi over 2. And we know that the tangent is negative 3 over 4. Okay, so whatever this is, we know that the tangent of this angle has got to be 3 over 4, right? Which means that the opposite over the adjacent is 3 over 4. So that means this is 3 and this is 4. By Pythagoras' theorem, that means the hypotenuse is 5, right? This is a classic 3, 4, 5 triangle. However, that said, if you're unsure why the hypotenuse is 5, just use Pythagoras' theorem, and that will help you solve it. But this is one we've probably seen so many times at this point that we know how to get there. Okay, so now we know now we can figure out what cos squared theta is and sine squared theta is. So what is cos theta, or I guess we're doing cos alpha. No, actually, let's switch this to, let's just call this theta. Why not? Okay, so cos theta would be adjacent over hypotenuse. So that's 4 over 5, right? And that is positive 4 over 5 because C, the cosine, is positive in quadrant 4. And then sine theta would be 3 over 5, and it would have a negative sign, negative 3 over 5, because it's opposite over hypotenuse, and the sine function in general has a, it's not cosine, and so therefore it's negative. And tangent is also negative, hence why negative 3 over 4 was the answer given rather than just regular 3 over 4. Okay, so now let's plug our answers in. So this would be cos squared theta, so 4 over 5 squared minus, let's see, negative 3 over 5 squared. So that's going to be 16 over 25 minus 9 over 25, which is equal to 7 over 25. Awesome. Okay. Then let's move on to the next one, which is going to be sine. We want to know the sine 2 theta 1. And we know from above that that's equal to 2 sine theta cos theta, which is equal to 2 times negative 3 over 5 times 4 over 5, which is equal to, well, let's see, 2 times negative 3 times 4 is negative 24. And then 5 times 5 is 25. So negative 24 over 25 is the right answer. Very good. So see what we did there? We, figured out, okay, if we're in this quadrant and the tangent is this, then here's what the sine and the cosine must be. And then we use that to determine the double angles using the formulas up top. So there were a few different skills that we used there in order to figure this one out, which is good. All right, let's do example 3 as well here. This is a bit of a bigger example. This one says, I know it's only one line, but it is a bigger example. You'll see in a minute. If cosine x is equal to 6 over 10, and x is between 0 and 2 pi, determine the value of cos 2x, sine 2x, and tan 2x. Okay, so first of all, there's actually going to be two answers to this because they said that cosine x is 6 over 10, right? Cosine x is 6 over 10. And, and it can be anywhere from 0 all the way to 2 pi, right? So they didn't specify a specific quadrant. They basically said it could be anywhere in the 4 quadrants as long as it's in the first cycle from 0 to 2 pi, then it's good. And so there's two possible answers for this. And that's done purposefully, I would imagine. I don't think that was a mistake on their part here with this question. So it could be this one, right? This could be 6, and then this could be 10, right? For a cosine of x. Or it could be this one over here, right? It could be this one all the way over here, where we have 10 here, like this, right? Because cosine is positive, and cosine is positive in quadrant 1 and quadrant 4. It is not positive in this quadrant or this quadrant. So these two quadrants we can rule out and say, well, that's not possible. Okay, so there's two possibilities here. So now we've got to figure out what sine x is and tan x is, because we already know that cos x is 6 over 10 because they told us. So what is sine x? Well, if we're using quadrant 1, then sine x would be opposite over hypotenuse, which we haven't calculated the opposite. The opposite is going to be 8 because this is a classic 6, 8, 10 triangle. This is a bit less common than the 3, 4, 5 triangle. So actually I will use Pythagoras' theorem quickly to show why that is. So it's going to be equal to, opposite is going to be equal to 10 squared minus 6 squared, and the square root of that, which is going to be 100 minus 36, which is equal to root 64, which is 8, right? So therefore it's 8 with just a quick Pythagoras' theorem, okay? All right, so given that that's 8, let's move on to what is sine of theta. Well, if it's in quadrant 1, then sine theta would be 8 over 10, right? And if it's in quadrant 4, then sine theta is, sine is negative there, and it'd be negative 8 over 10. So both of these are possible answers because it could be either one of them. We're going to determine it with all different values here. Okay? Same with tangent, right? Tangent could also be two different answers because if it's quadrant 4 that we're looking at, then it's going to be a negative answer. And if it's quadrant 1 we're looking at, it's going to be a positive answer, right? So let's see here. Tangent theta is going to be equal to 8 over 6, or tangent theta is going to equal negative 8 over 6. And that's that. Okay, so now they want us to determine what is sine 2x, cos 2x, and tan 2x. So let's go ahead and do that. So for sine 2x, it's equal to 2 sine x cos x, right? And we know cos x is 6 over 10, but there's two possibilities for what sine x could be. So one answer is that sine 2x is equal to 2 times 8 over 10 times 6 over 10. And then the other answer is that it's sine 2x is 2 times negative 8 over 10 times 6 over 10. So basically all I'm doing here is I'm accounting for both possibilities because there is more than one in this situation. Okay, so now let's multiply that out. Let's see, 8 times 6 times 2. Let's see here. 8 times 6 times 2 is 96. Divide by 10 is 9.6. So 9.6 is one answer, and then this one would just be negative 9.6 for that answer there. All right, now what about cos 2x? Well, cos 2x is equal to cos squared x minus sine squared x. And the thing is, even though technically there's two possible values for sine x, they actually will both lead us to the same answer. So there'll be only one overall answer here, because whether I plug in 6 over 10 squared minus 8 over 10 squared or negative 8 over 10 squared, well, so we'll just say plus or minus 8 over 10, it's going to give us the same answer. So we're going to account for both possibilities, but it's actually only going to give us one answer in the end. So then we're going to get 36 over 100 minus 48 over 100 which is negative 12 over 100, which is negative 0.12 in the end. Awesome. All right, and then let's go on with tan 2x. So what is tan 2x? Well, let's think about that. Well, that is going to be 2 tan x over 1 minus tan squared x. Okay, so for this one, we are going to need to do the two answers thing once again, because even though we have tan squared x in the bottom, we have just regular tan x in the top. Okay, so our first answer for this could be that tan 2x could be equal to 2 tan, tan x we already figured out. Or I mean, I used theta, but I actually should have said x for all these. But regardless, 2 times 8 over 6 over 1 minus 8 over 6 squared. Or number 2, it could also be tan 2x is equal to 2 times negative 8 over 6 over 1 minus 8 over 6, negative 8 over 6 squared. So this one is going to be 16 over 6 over, let's see, 1 minus 64 over 36, which is equal to negative, let's see, what's that going to be equal to? Well, let's see, what's 1 minus 64 over 36? So 64 over 36. This one. Okay. So this is going to end up being 24 over 7, which is approximately 3.43. And then therefore this one is going to end up being negative 24 over 7, which is going to end up giving us negative 3.43 approximately. And so there we go. So now we figured it out. We were able to determine what the value of cos 2x, sine 2x, and tan 2x were because of the information that we already know about trigonometry, and also because of these double angle formulas that we just learned. So that's it for double angle formulas. Next time we'll talk about solving linear trigonometric equations. So good work today, everyone, and we'll see you for the next one. Bye, everyone.